Hello everyone, welcome back to Spectrum classes. In this video, we are going to solve the equation for simple harmonic motion and we are going to deduce its solution, which is very important. So here I have written the equation y is equal to a sine omega t. Here y is the displacement. So simple harmonic motion within this cycle we are again and again representing. Here y is this and amplitude, maximum amplitude is this. Y max, right? Here this is the maximum amplitude and it is represented by a and it makes an angle theta. So theta is omega t because this particle frequency for this particle is omega and t is the time. So this is the equation for simple harmonic motion. Now if I just want to see the velocity, so velocity is dy upon dt with respect to time, and if I differentiate this equation number 1 with respect to time, then what I get the velocity. So here a omega sine will convert into cos omega t. So this is our velocity. This we have derived mathematically as well as geometrically in previous videos. Now if I just want to deduce the acceleration, then what I need to do, I need to differentiate my velocity with respect to time. So dv upon dt, and this will be, since v is equal to dy upon dt, so dv upon dt is equal to what it will be, this will be d2y upon dt square. So here d2y upon dt square is equal to dv upon dt, and this will be equal to, it means we are just going to differentiate this equation again. So a, now omega square and cos omega will convert into minus sine omega t. So this is how we are just going to get this d2y upon dt square, which is equal to acceleration. Now I am just going to change this equation in this form. So here d2y upon dt square is equal to alpha, and this is equal to, from this side we are just having minus omega square y. So from where this y comes? So y is equal to a sine omega t, which comes from this equation number 1. So this alpha will be equal to minus omega square y. If we apply for Newton's second law, then F is equal to ma. A means acceleration, alpha. So here on putting the value of alpha, which is minus omega square y, so we get this force in minus terms, which is the condition for simple harmonic motion, because this force is in opposite direction to the displacement, and this is also known as restoring force, right? So this is the condition for simple harmonic motion. Now moving further, so this equation can be written in this form, and if we consider that this omega square is equal to c, this omega square is equal to c, then omega is equal to under root c. On putting this value in this equation, then what we will get, in place of omega square I have just written c. So we are going to get the solution for this equation. Here this is in terms of y on the left hand side, this is also in terms of y, and here multiple of y is c, right, minus c. So here I am just going to highlight this. Now I am just going to assume a solution for this equation. So the solution for this equation, because it is double differentiation, so in the solution there will be two constant terms, a and b. So if it is having two constant terms, then the solution is assumed as a cos under root c, this is in form of under root, and into t. T is with respect to what we are just differentiating this equation. Now plus b sine under root c into t, right? So this I am just going to tell you, if we are having say d2x upon dt square is equal to minus c into x, fine. So the solution for this equation is in terms of x is a function of t is equal to a, because this is double differentiation, so a cos under root c into t, right? So with respect to t we are just differentiating this, so here coefficient into with respect to what we are just differentiating it, plus b sine under root c into t. Now the question comes how to evaluate these two constants. So to evaluate these two constants a and b, we need two conditions, because from one equation we can calculate only one unknown variable or constant. So to calculate two constant we need two equations. So we are having two different options. First is either displacement and velocity at time t, we must know, or we do have the values of displacement at two different times. So these two choices we are having, right? So to evaluate this a and b, say if we apply the condition at time t is equal to 0, y at time t is equal to 0 will be y naught, and v at time t is equal to 0 is v naught. So what I need to do? I need to put, because this is in this equation number 1 is in terms of y only. So y, I'm just going to put y at time t is equal to 0 is equal to a cos t is equal to 0, this will gives 1, and sine t at time, if I put 0 here, if I put 0 here, then I will get 1 and this will be 0. So b will be b into 0, right? This. So a will be equal to y at time t is equal to 0, which is y naught. So a is equal to y naught in this manner. I'm just going to show you here. So a is equal to y naught. What about velocity? So velocity, how I am just going to get it, this is displacement, this is the solution for displacement. Now how I will get the velocity? So to get the velocity I must differentiate this equation with respect to time again. So we will get this is our equation number 2. Now as we have the value for the velocity at time t is equal to 0, so this is equal to v naught. Now I am just going to put this is v naught at time t is equal to 0, and if I put t is equal to 0 here and t is equal to 0 here, so what I will get? I will get b under root c, because this whole term will be equal to 0, and here cos 0 will be equal to 1. So here v naught is equal to b root c, and b will be equal to v naught upon root c. So from this equation we can also evaluate this. B is equal to v naught upon under root c, and a is equal to y naught. So these two are the solutions, possible solutions for this velocity and the displacement. So b is equal to v naught under root c, or we can also put the value for this under root c, which is equal to omega. So omega is the frequency as well as velocity, right? So this is the solution. We are also calculate this solution mathematically, we can understand. So I'm just going to show you here by different method. Say this is our equation, d2y upon dt square is equal to minus cy, and the solution is in this form. There we have the solution in different form, but here we will start with this only, right? So if we say that this is the solution for this equation, y is equal to e power lambda t. Now I'm just going to differentiate this equation. So dy upon dt will be equal to our velocity. So velocity is equal to this one. So lambda is the multiple of t, so it will come outside. Now I'll just going to double differentiate it. So on double differentiation I will get lambda square e power lambda t. Fine. So here I am just going to put this in equation number 1. In equation number 1, I am just going to put d2y upon dt square as lambda 2 e power lambda t is equal to minus cy. And if I'll see this e power lambda t is my y again, then I will get lambda square y is equal to minus cy, and y will be cancelled out by this y. So lambda square will be equal to minus c again. And if I solve it, then lambda square is equal to minus 1 will be equal to iota square. So this is my iota square into c. So lambda will be is equal to I under root c. This is what we get about this lambda. So I am just going to show you here. There will be plus minus sign. So if we put the value in this equation, e power y is equal to e power lambda t. So lambda is our plus minus iota under root c. So we are just having two values for this y. One is with plus and one is with minus. Now, as we know from the Euler's equations that e power I theta will be equal to cos theta plus I sin theta. Similarly, e power minus I theta is equal to cos theta minus I sin theta. So here we are having two things. One is real and the other one is imaginary. So here this imaginary and our real part, so this is our real part and this is our imaginary part. So on putting the value of e power it and e power minus it in this equation, then what I will get? I will get this a1 into e power I under root t. So in place of that I'll just written over there b1 e power minus under root ct. So I have written over there. Now I'm just going to separate it. So on separation, I will get a1 plus b1 is cos under root ct plus I a1 minus b1 sin under root t ct, right? So this is our equation on further solution. Now I can just have a general solution which we have taken in previous slide. So yt is equal to a cos under root ct b plus b under sin under root ct. So here what is a? A is our a1 plus b1 and what is b? B is our imaginary value or imaginary component a1 minus b1. So these are the values here. So this is the mathematical derivation of this general equation, and on the same way we can put the values at time t is equal to 0, at yt is equal to 0, we at time t is equal to v naught, then we get the same things. A is equal to y naught and b is equal to v naught upon omega. So you can memorize these two also. We have just derived these and you can memorize also, right? Because direct questions will ask from here. Now I'm just going to solve a numerical problem on this concept. So here problem is given like this: find the solution for equation this, for which x is equal to at time t is equal to 0 3 meters and v velocity at time t is equal to 0 is minus 2 meter per second, right? So the solution, so general form is given in this form which I have written over here, but here instead of y we are having x, so it can also be replaced with x. We consider the solution in this form, that c is equal to our here c is equal to 25 5 square, right? So under root c is equal to 5. Now here I have just put the value of c, that is minus 5 square, and now the solution for this kind of equation is like this. So what is our under root c? Under root c is 5. So we are just going to put here 5, and from this equation we can evaluate a and b because conditions are given. At time t is equal to 0, x is equal to 3 meters. So what I told you earlier, x is equal to, at time t is equal to x naught, or here it is 3 meters. Direct question, right? So here a is 3 meters. Now what about velocity? So from velocity we can evaluate b is equal to v naught upon omega. So what is our v naught? V naught is minus 2 upon omega. Omega is what? 5. This is equal to omega 5. So this is 5, and the velocity is meter per second and this is meters omega, right? And if we cancel out this, then we will get b is equal to minus 2 upon 5 second inverse, right? So this is the answer. I have also shown like this. This is the answer. I hope you find this video helpful. If you find this video helpful, please like, share and subscribe. Thank you all. Thanks for watching.